The LITENING II pod on the Hornet has undergone many changes since release, so it's time for a complete new guide to all its features. The LITENING II Targeting pod is a high magnification monochrome TV and IR camera system with laser spotting, targeting and marking abilities. We can mount it on either the centre or the left fuselage cheek station. This is a large, complex topic with lots to go over, being a crucial system on the Hornet for air-to-ground engagements. As always, timecodes are available for each topic in the description and on screen. I would recommend taking some notes as you go along. Let's get started with the setup for use. With the pod mounted, we need to warm it up. On the right hand side panel, set the FLIR switch to the standby position. Open up the FLIR page on our MFD and we'll see ready crossed out and not timed out shown, indicating our pod is still preparing for use. This will take about 2 minutes, after which we will see the display switch over and show standby. The pod is now ready to use but stowed. Move the FLIR switch to on to use, or if you're in a hurry you can skip the standby stage and go direct to on before warming up, where it will automatically switch out of standby mode once ready. You should also set the laser target designate / ranging switch to on once operational. This is an electronically held switch which will only stay in the armed position if the air-to-ground master mode is selected and the pod is ready for use. The pod will remain stowed until we give it its first command. Before using our pod, we'll assign the HOTAS controls to it by pressing the sensor control switch in the direction of our display, setting it as our sensor of interest or SOI, which is denoted by a small diamond in the top right of the display. The FLIR can be on any display, with the center display showing grayscale rather than greenscale. We'll go over all the on-screen information and buttons next. Starting from the top, we've got the pod status now showing operational. Beneath that, the tracking mode will display showing none, point track or area track. Our field of view toggle, wide or narrow. The narrow field of view is visualized in the wide mode by the 4 boxed corners within the display. The coordinates our pod is looking are shown below for quick reference in degrees, minutes, decimal minutes, along with barometric altitude of the ground level in feet underneath. Freeze will show a still image. This can be useful if you wish to examine a picture but cannot hang around to maintain sight on target. The pod will continue to track on its own in the background. Press freeze again to resume video. Below freeze we've got the degrees left or right of our nose the targeting pod is looking. The angle the pod is looking up or down is shown on the left center, and we have the laser arm status, showing that the laser is currently armed. Pressing mark will select the marking laser and show mark armed. It will also box trig on the right. This indicates that pressing the trigger will engage the laser marker. Pressing trig without mark selected will allow you to fire the designation laser manually by pressing the trigger down. When firing the laser target designator / ranging and symbology will flash. Top right we've got the north arrow. This is shown relative to the ground as shown by the video to help you orient yourself and the image that you're seeing. Next to that, the sensor of interest or SOI is indicated. Reticule allows us to hide or show the crosshair reticule. VVSLV, which when pressed slaves our targeting pod to our velocity vector. The slant range, or the range directly from our aircraft to the point the pod is looking at in nautical miles. Our currently selected laser designation code, and UFC. Pressing this allows us to edit the codes on the upfront controller. Grey opens the display calibration tool, showing you the darkest to brightest levels of our display. If lots of objects are full bright, you can adjust the contrast levels until only a few hotspots are full bright for better clarity. Along the bottom we've got our own aircraft's Mach number, airspeed and altitude. Declutter to hide unnecessary information if desired. Our laser spot track target code and LST button, which will enable the laser spot tracking mode. Coming down the left side we've got our zoom level. We can push the arrows to zoom in or zoom out on screen. Bottom left we have our roll and pitch indicator. The solid semicircle represents the ground and will always point toward it, with each tick mark being about 30 degrees. When you roll your aircraft, the semicircle will roll with you, continuing to point downwards. This is not to be confused with the pod's camera feed, which will stabilize itself independently. Each tick is 0, 30, 60 and 90 degrees of roll. For pitch, however, we'll see the semicircle grow or shrink. As we climb, the semicircle will shrink with each tick it passes being 30 degrees of climb, and conversely, if we dive, we'll see the semicircle grow again, each marker being 30 degrees. So, a vertical dive would result in a complete circle, whilst a vertical climb would result in no circle. On the velocity vector symbol we have indicators for angle of attack. When we exceed 7 units of AOA, we'll see a triangle start to extend. This will jump out fully when we exceed 12 units of AOA. A small line will descend from the top until it reaches about 20 units of AOA. This is a good warning that your aircraft is either too slow, or you're attempting to turn too tightly. Lastly, in addition to all this, it will repeat the bomb fall line and release cues from our HUD for our weapons release when we perform an auto attack, for quick reference in case we need to make adjustments on the run. Returning to the FLIR page, on the bottom left we have our camera mode, either charge coupled device, better known as a TV camera, and we can press the button to toggle FLIR or the infrared camera. With FLIR selected, we've got a few new options. We can select white hot or black hot polarity, changing the colour of hot objects. Sometimes it is easier to spot with one over the other. ALG, automatic level and gain. When selected, the computer will attempt to automatically compensate for lighting changes. Whilst this will work most of the time, sometimes we'll need to override this by deselecting it. This allows manual gain and level control by pressing the zoom button to switch to level or gain instead of zoom. The current settings are shown just to the right. We can then return back to the automatic mode by reselecting ALG. The autofocus button is not implemented at the moment, but it would trigger the computer to refocus automatically on its current target. Beside our crosshair reticule, you can see the meter stick scale. This is the length each leg of our crosshair represents on the ground. You can use this to line up one leg with the crosshair and estimate the size of objects or the distances between them. Within the display we've got the directional cue. This little diamond points in the direction a pod is looking, relative to our own aircraft, with the centre being directly below the aircraft and the edges being level with our wings. In this example we can see the pod is looking about 30 to 40 degrees below the level of our wings. Outside the display we can also adjust brightness and contrast with the knobs below. Let's go over Hud Symbology next. The Hornet does not have any dedicated FLIR symbology, however it does reuse system symbols. If the laser is armed, we will see a repeat of the laser status on the top of the HUD, just like the FLIR page. Whenever the FLIR is in point or area track, we will see the word FLIR on our HUD. This will flash if the targeting pod is masked by its own housing. The targeting diamond will show when a point has been designated with the pod, dashed when in a slewable mode, and solid when in point or area tracking modes. Just like any other designated point, we have the range cue and will receive steering cues on the HUD when pointed away from our target. After dropping a bomb we will see the time until auto lays, or the time until impact on the right. Lastly we've got the velocity vector, which the targeting pod can be slaved to. In addition to the HUD, we've got a small box shown on our SA page. This represents the location on the ground our targeting pod is currently looking. Let's now get into using the pod's HOTAS controls. In order for our HOTAS to interact with the FLIR, we need to set it to our sensor of interest or SOI. Press the sensor control switch in the direction of our display to select it. A diamond top right indicates the display is selected. With it set, HOTAS controls will now interact with the FLIR page. The controls are as follows. The sensor control switch, pressed in the same direction as the FLIR page, will cycle tracking modes. The RAID/FLIR FOV select, short press, will toggle between narrow and wide zoom levels, and long pressing the FLIR/RAID FOV select button will toggle between TV and IR camera modes. The throttle designator controller, or TDC, is used to slew the camera about. Pressing the TDC depress will designate a target if not already set, in which case it will enable the offset cursor in point track or area track modes. The radar elevation control up or down controls our zoom level. Cage uncage will toggle laser spot tracking on or off. Undesignate/nose wheel steering switch will undesignate the pod and put it into snowplow mode. Quickly double pressing the undesignate/nose wheel steering switch will set you in velocity vector slave mode. Lastly, pressing the trigger will fire the laser if manual lasing is selected by boxing trig. Now at last we can get into actually using the pod and the fun part, blowing stuff up. I'd suggest using the zoom control to get an intermediate zoom level and then make use of the wide and narrow field of view to quickly inspect points of interest without having to slowly zoom in and out repeatedly. Pressing SCS towards our display cycles between area and point track modes. This is based on image contrast. If there is little or no contrast, you will struggle to achieve a good track. If no track mode is shown, the pod is operating in an INS ground stabilized mode, which allows us to slew the camera. This mode may drift over time however. When in point or area track, we cannot slew the pod anymore. Pressing SCS towards our display a couple times, we can cycle back out to allow slewing once more. Using the TV camera, a point track can typically be acquired about 6 miles out, whilst the IR camera can track from about 12 nautical miles. If you're looking to follow a moving vehicle with a pod, you need to place your crosshair into the path of the vehicle and then press the SCS to cycle to point track as it passes into your crosshair, and it should pick up on your target. Remember to avoid masking your pod or you'll drop the track and it will revert back to a stabilized ground track. Lastly, I want to cover area and point track offset mode. In DCS this is of limited function, but I feel it is important to explain its purpose and compare to the real world use to avoid confusion. When you are locked in area or point track, pressing the TDC depress will enable the offset cursor. If you then slew it over to a new point and press TDC depress once more, you will move the designated point without moving the targeting pod. It's important to note that we've only moved the designated point and that the laser will still fire directly at the crosshair. If we set the SCS to our display again after setting an offset, our pod will jump to the new offset. So why is this more useful in the real world than DCS? Well, in DCS our targeting pod has a much better ability to maintain a lock on objects and terrain, whereas in real life this is not so much the case, making dim, low contrast objects unreliable to lock. So you would lock up a bright hotspot nearby and then offset our target point to our intended target. This lets you maintain a good track locally, even if the pod cannot directly distinguish our intended target. You could then deploy a GPS guided weapon directly onto the designated target on the offset, or during a laser guided attack it allows you to drop on the offset point, and then you can hit SCS to jump to the intended target and maintain a track manually with the slew controls when it's time to fire the laser. In practice this is mostly unneeded in the context of DCS, where you'll probably be able to get by just fine without it. After our standard tracking modes, we've got a couple more to look at. Snowplow mode is the default mode when you're not actively tracking the ground. This simply faces our pod forwards and angled down in our flight path. Its purpose is to allow you to search the ground in your path, potentially allowing you to spot a threat or see landmarks. It's entered by simply pressing the undesignate/nose wheel steering button. It's not ground stabilized, so you can freely slew around. You can hit TDC designate to target the ground and stabilize it whenever you want. Hitting undesignate will return you back to snowplow. Velocity vector slaving is a very important mode that you'll be making heavy use of. By pressing VVSL on the display or double tapping the undesignate button rapidly, our pod will slave to the velocity vector on the HUD. This is ideal for visually acquiring a target. You can spot your target, fly directly at it, and then press TDC depress. This allows us to get our pod onto targets of opportunity that we've spotted with our eyes with ease. If you're dropping bombs in CCIP mode, the pod will slave to the predicted impact point of our bombs. You cannot slew the pod in this mode, however. It allows you to use it as a primitive bomb sight and help you fine-tune aim if you're struggling to visually acquire the target through your HUD. It can also provide laser range finding to help improve the quality of our CCIP solution. We can slave our targeting pod to waypoints by simply hitting the Waypoint Designate button on our HSI or SA page. This will slew the pod rapidly to the coordinates of our waypoint. If our waypoint is not set correctly to ground level, however, you will need to correct this manually by editing the waypoint, otherwise the pod will be attempting to follow a spot in the sky, which is not terribly useful. Our ground radar can also be used to target the pod. Simply designate with the surface radar and the pod will slew over to that point. Lastly, we've got the dedicated air-to-air modes, enabled by entering air-to-air master mode. By default, this slaves to our velocity vector, so you can simply fly the vector over an aircraft you can see and hit sensor control switch to our display to start tracking. This will show up on our HUD as a box with an F for FLIR below it. We can then go and hit slave on our FLIR page to slave the radar onto the target tracked by our pod. With two tracking sources, we'll see the letter C under the box indicating a correlated track by both the pod and our radar. Alternatively, if we are tracking an aircraft with our radar already, we can hit the RRSLV or radar slave to slave the pod to our radar's target. Just like air to ground, we can use the zoom and field of view controls to inspect the aircraft. This is perfect for identifying aircraft prior to an interception or to help you spot missile launches by hostile aircraft. Before we get into weapons employment, let's quickly go over programming the laser on our pod. The Lightning II has both laser designation and ranging, along with IR laser marker and laser spot tracking. It's got an approximate range of 10 nautical miles in designation and marking modes. We'll set our laser codes. Ensure you've got your laser switch armed. On the FLIR page, we'll hit UFC. This opens up the upfront control options to change either the laser designator code or the laser spot tracker code. Select an option and we can enter a new code. If you enter an invalid code, the input will flash before discarding it. Codes must always start with 1, the second digit must be 5, 6 or 7, and the last two digits must be between 1 and 8. You should always ensure that your laser designator code matches your weapon. You can see the selected codes on the FLIR page. By default, our laser will fire automatically when required by our weapons. If you like to fire the laser manually, however, you can hit trig. Now when we hold down the trigger, our laser designator will fire. To use the laser spot tracker, you need to hit UFC, select our laser spot tracker code and enter it. Then we need someone to provide the laser for us to track. In this example we're going to use a JTAC, but you could of course use any other aircraft or unit that provides a laser for you. So we will command them to turn the laser on.
Uzi, 1-1, laser on. Laser on. Blazing.
With the laser on, we now need to tell our pod to go into laser spot track mode, so we will press the cage uncage button. Alternatively, we can press the LST button on the display. Once we are within LST mode, we will see the image has blanked out, and we now have the option to toggle between narrow and wide field of view searches. With our pod in laser spot tracker mode, we now need to fly roughly towards the area that is being designated, and the pod shall automatically pick up on the laser for us. Our pod will continue to follow the laser spot even if it moves, as it remains in laser spot tracking mode whilst displaying video. We can now zoom in and inspect our designated point. From here we could employ weapons for our buddy laser to direct, or if you wish you could manually take control by pressing designate and then switching back to the stabilized track mode with the SCS towards our display. Lastly, we've got the laser marker, which is visible under night vision goggles. Hit the mark button on our FLIR page and you'll notice trig is boxed automatically. Now when we press the trigger, the marking laser will fire, making it very easy to point out targets to anybody nearby who has NVGs on. We'll quickly go over weapons employment with the pod, but for more detailed looks of each weapon I've included links in the description for dedicated tutorials. Starting first with laser guided bombs, all you need to do is find your target and designate it. Follow the steering cues on your HUD, and as it passes the release cue, press and hold the pickle button. On the right you can now see the time until laser counting down. When this reaches 0, it will switch over to the time to impact and the laser will begin firing. Ensure the pod is not masked during the attack, and your bombs should arrive on target. Once the attack is complete, the laser switch will automatically return to the safe position. Do not forget to re-enable this before your next attack. To use a laser guided Maverick, open the Laser Guided Mavericks page, ensure you have the laser code set, and then locate your target. Designate it, and then press your sensor control switch onto the display your laser Maverick is located. The display then needs to be uncaged by pressing the uncage button, after which it will slew to your designated point. Then, once we are within range, all we have to do is press and hold the pickle button. Ensure that your laser is armed, hold down the pickle button, laser fires, and the Maverick will release automatically. The laser will continue to fire for you until shortly after target impact. Note that there is no time until impact provided for Mavericks. For IR guided F-model Mavericks, we need to ensure that our missiles have had the time to cool down and are ready to use. With our Maverick now warmed up, we simply need to find ourselves a new target. So it is designated. We will now press sensor control switch to our display with the Maverick, and we will press the uncage button. The Maverick will now slew to the rough point our targeting pod is looking, and attempt to acquire a lock. If it fails, you will need to cage and uncage once more, until it does achieve a lock. With it locked, we can now fire when within maximum range. So we pass in range, hold down the pickle button, rifle. We're now free to disengage and maneuver at will. Once again, there is no cue or time until impact provided on the HUD or FLIR page. In a cluttered or busy environment, the Maverick may not pick up your intended target. In this event, it may hit a target nearby or behind or in front. In this situation, it is much better to use a laser guided Maverick instead, because you can ensure it hits your intended target. To quickly attack a target with JDAMs or JSOWs, you first should select Target of Opportunity mode after aligning your JDAMs or JSOWs. With Target of Opportunity selected, we'll now open the JDAM display page, and we'll go to the mission page, and now for Target Opportunity 1 we can see the coordinates. We now simply have to slew the pod onto our intended target. As you slew the pod around, note that the targeted coordinates for TOO have been updated to match where the pod is now looking. All we have to do now is simply fly to our target and press the pickle button to release, and the bomb will find its way there. Once our nose is on target, we can release with the pickle button and turn away. If we wish to attack two targets with JSOWs or JDAMs, we first need to locate our first target, and having set it now in TOO, TOO1 is set as our first target, and we will now press TOO2. TOO2 is now automatically set to the same target, so we'll slew it away to our second target. And now, once we are happy with the position of our target, we have our two targets set. We should now press Undesignate. This stops the pod overwriting our TOO targets. As we pass within maximum range, we can now attack our targets. If we press the pick and release button, we will release our first bomb. We'll step back to our station that we have pre-selected and we'll pick TOO1. And now we will press the pickle button once more to release our second bomb. Now both bombs are going off to their individual targets. If you do not press the Undesignate button on your targeting pod, you will overwrite the first target the moment you select it, so make sure to undesignate first. When using JDAMs to attack multiple targets, it is advisable that you create a waypoint of the general target area so you can slave back to it for quick reference as you do your attack, because you have to undesignate your commands in order to prevent overwriting your targets of opportunity. To round it off, we'll go over a few Hornet specific tips and tricks. We can make use of an AGM-88 HARM missile in TOO mode to cue our targeting pod onto a radar site manually. You simply select the emission type from the HARM TOO page, and then on our HUD we can see a directional target box. If we put our pod in velocity vector slave mode by pressing sensor control switch to the FLIR and then double tapping undesignate, we can simply fly it into the box and press designate. This should put you roughly on the SAM site and you can then fine tune your aim. This works best at moderate to short ranges. On the SA page, our targeting pod is represented by a box. We can use this to slew our pod into the centre of a SAM threat ring, and provided the intelligence is accurate, we can use this as the basis to search for a SAM site. Whilst you're orbiting around the target area, don't forget you can make use of your autopilot in altitude hold mode to maintain your orbit for you, and that you can set altitude warnings to avoid accidentally flying too low. The only major feature that is currently missing is the bullseye display on our FLIR page. Just like our radar and SA page, we will be able to display the bullseye for easy communication of targets when implemented. Lastly, I'd recommend using Markpoints with a targeting pod, which you can find my video on screen or in the description. If you've made it this far without going cross-eyed, congratulations! We've now gone over all of the features of our Hornet LITENING II Targeting pod. I hope this has helped. Happy hunting, and take care.